Okay, so in this problem we're going to talk about a half-life. And again, half-life has to do with radioactive material and how long it takes to decay or decompose, or however you're going to say it, to half the amount. Now, kind of a cool thing happens with this, and I'm just going to go ahead and show it to you on the example that we have. Okay, so it says the half-life of carbon-14. Now remember, this is just an isotope, carbon-14, that's radioactive. But the half-life is 5,730 years. Okay, so we know how long it takes for an amount of carbon-14 to decay to half the amount. Express the amount of carbon-14 remaining as a function of time. So in other words, they want us to come up with a function. So I'm going to go ahead and write the model. Now it looks like a lot of variables, right? We don't know an initial amount. We don't know time. We're going to know time. We don't know what K is. Okay, and we don't know how much we have after the 5,730 years. Okay, but here's what we do know. We know that after the time, if T is 5,730, so after that many years go by, we'll only have half of the initial amount. So what I do is I substitute over here, I say half of the initial amount is equal to the initial amount, e to the k times 5,730. Okay? Now, and you might say, but I don't know the initial amount. That's okay, because we're going to divide both sides by a naught, and that's going to take care of it. So I get 1/2 equals e to the 5,730k. So I'm going to write it that way. Take the natural log of both sides. So the natural log, I'm going to make my 1/2 a decimal. It's just easier to write that way. And then I have the natural log of e to the 5,730k. But remember, the purpose of taking the natural log is so that the right-hand side, that's just going to be 5,730k. And then I still have the natural log of 0.5. And I can figure out what that is. Yeah. Okay, so I'm going to go ahead and divide both sides by 5,730 so I can figure out what k is. This then is k. It's not the answer, but it's k. Now go back to our function, our model. Now I have k, and I'm going to say it's the natural log of 0.5 divided by 5,730, and then all of that times t would be the exponent. Okay, all of that big mess is the exponent. So if I knew how much carbon-14 I started with, then I could have a formula for figuring out how long it's going to take to decay to a certain amount. Okay, that is the formula that we're looking for. That's the answer. Another thing we can do is we can figure out what that is as a decimal. So take your calculator and go natural log 0.5 and divide it by 5,730. And I get k is approximately negative 0.000121. Okay. It looks like in the textbook they wrote it wrong, but that's okay. It wasn't part of the answer. This was just something they wanted to point out. Notice that it's negative, and that means it's going to be a decay, which we knew that. We knew we were getting less of the carbon-14 as time went by. But just to show you, it does turn out to be a negative. k, and so that means it's going to be a decreasing function. Well, not like that, but something like that. Okay,